this screencast we're going to look at the relationship between frequency and radians. Let's say we have an item here and we're going to rotate it about a radius r at an angular velocity omega. As it rotates, it will create a circle. So it rotates in this sort of pattern. Now let's say it completed the cycle in 1 second, or we can say it did 1 cycle in 1 second, or 1 cycle per second. We know that frequency is cycles per second, so if it rotated 1 cycle per second, it did so at a frequency of 1 Hertz. However, we know that it's rotating at an angular velocity omega. So omega is the number of radians per second, and that's approximately what 1 radian would be. But we know that in a full circle there is 2 pi radians. So a full cycle in 1 second means we've done 2 pi radians per second. And we know that omega is equal to radians per second. So I can say that the angular velocity in this case was 2 pi radians per second. Now let's say we rotate the item twice as fast. Okay, so it's going to do 2 cycles in 1 second. So the angular velocity would be 2 pi radians per second multiplied by 2, because we've done 2 cycles in the 1 second. That would give us 4 pi radians per second. And that would look something like that. Therefore we can see that the angular velocity omega is equal to 2 pi times the frequency. So 2 pi times the frequency is equal to the angular velocity. And that concludes our screencast.